Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level other type puzzle, and it's specifically a tessellation, which is kind of similar to Sudoku's, but um, not completely, so we've basically broken it out into a different type. Anyways, it's called Dutch Arrow Tessellation by Michael Lefkowitz. And here are the rules. We have tessellation, where we need to fill each cell with a digit from 1 through 9. And cells sharing an edge cannot have the same digit. Also, so basically, for example, if this were a 6 here, that would mean every digit that shares an edge with it, which are these 8 digits, cannot have a 6. Each horizontal row and vertical column contains non-repeating consecutive sets of digits, like 2, 3, 4, 5, 6 in any order. So this, for example, could be something like 3, 4, 5, 2, and 6, and this would be valid because it's a non-repeating set of consecutive digits. Actually, I would prefer calling it non-repeating set of consecutive digits, right? Non-repeating consecutive set. I guess that works also. Non-repeating consecutive set of digits. I don't know. I'm not sure whether it really changes very much going from one way to the other. But as an example, this would be valid. As an example that does not work, say we had an 8 here. That would not be valid because they don't form a set of consecutive digits, right? 3, 4, 5, 6, 8 is not consecutive. And that's basic tessellation. We also have Dutch arrows, where a digit on an orange arrow indicates how many digits in the indicated direction differ from it by at least 4. So, for example, if we had, well, we know this is the digits 1 through 9. Actually, it's kind of solving it. Anyways, this digit, say it had 4 digits along this row, which were 4 away from it. Then 4 or more away from it. So say this was, well, it would have to be 4 then. Okay, so it can't be 4. Say this was a 3. This would then have to have 3 digits in this direction, which were 4 or more away from 3. So you could have something like 9, 8, and 9 here. And that would be valid, because in this direction we have 3 digits, which are 4 or more away from itself. Right? Anyways, those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, these are the digits 1 through 9 guaranteed. Okay, so these digits can have 4 digits which are 4 or more away from it at most. So this is 1 through 4. This can have 3 digits that are 4 or more away from it, so that's 1 through 3. This has digits that are 4 or more away from that, so that could be 1 through 4. So this has to be at minimum 3, 4, 5, 6. This digit has 1, 2, 3, 4, 5 digits possible that are 4 or more away from it. But the thing is, 5, especially in the same row, doesn't work, right? If we had a 5 here, the digits which can be 4 or more away from 5 are only 1 and 9. So that doesn't work for 5. Also, 4 doesn't work because if this was 4, the problem is 4 only has 2 digits, which could be 4 or more away from it, if there are only unique digits in a set, in a direction. So this can't be 4. So we have a guaranteed this has to be 6 with 5, 4, 3, and 2. So this has to be 5 here. This has to be a 2, 3 pair here. And then this has to be 4 here, because there's no other possibilities for this as a consecutive set. So this has 2 or 3 that are going to be 4 or more away from it in that direction. This has to be 2 or 3. And in addition, so let's continue with this part, right? In here, we have the digits 1 through 9. The most so you can only have at most 5 digits which are away from 4 or more away from a digit there. And the thing is, 5 itself is only 4 or more away from 2 digits. So 5 does not work. 4 does not work. Therefore, this is 1, 2, or 3 here. 1 doesn't work because 1 does not have... 1 has 5 digits that are 4 or more away from it, from the digits 1 through 9. 2 doesn't work because 2 has only... 2 has 4 digits, which are 4 or more away from it, 6, 7, 8, and 9. And so this has to be a 3 here. So this is 3, which has definitely 3 digits in this row, 1 through 9, which would be 7, 8, 9, which are 4 or more away from it. Now this digit is not 4 or more away from it, so this cannot be 4 here. So this could be 1, 2, or 3 in this direction. We don't know. This has all 4 of these being 4 or more away from 4, which means these are all 8, 9. Interesting. Well, since this is 8 or 9, that means this has to be 4, 5, 6. It could be 4 up to 8, or it's obviously no 6. So 4, 5, 7, 8, 9. So it's 4 through 8, or it's 5 through 9 here. This is definitely 4 or more away from 1, 2, or 3. This is definitely 4 or more away from 2 or 3 here. These have to be consecutive with the digit. So if we try to have 3 here, so this digit cannot be 2, 3, or 4 here because they all share an edge with the 4, the 2, and the 3. So this has to be either 1, 5, 6, 7, 8, 9. This digit cannot be 5 or 6, so we have 1, 2, 3, 4, 7, 8, 9. If we had a 1 here, the problem with that is this would have to be 2 and 3 as a pair, which would eliminate all possibilities for that cell, so this can't be 1. And also this can't be 1 for this, because this would have to be a 2, 3 pair. Well, we know now this is 5 through 9 here, and 5, 4, and 3 is the minimum you can get there. So this has to be 3 through 9 here for this set. If we had a 2 here, that would mean... So 2 through... Can we have 2 through... We could have 2 through 8. So if this were 2, we would have to have 2 through 8 here. You'd have 8 there. So if this is 2, it's 2 through 8. If this is 3, it would require it to have 7, 8, and 9 here. So then it would be 3 through 9. So first of all, we can never have a 1 here. And 2 or 3 signifies what digit is there. So the rest of the digits cannot be 2 or 3. We have 4 through 9 here. These digits are different. So, and these digits are different because they share an edge. So therefore, this cannot be 8 or 9. This can't be 8 or 9 for the same reasoning. So these digits are different. So we know these 2 digits have to be the same, and these 2 digits have to be the same. So let's mark those. This is the same as that. This is the same as that, right? Because these have to be different digits, but they have to be 4 or more away from 4. So both of these cells see this. Both of these cells see this. So neither of these could be 8 or 9. This for a set can never have a 1 because for a 7-cell Renban, which is what these are essentially, 1 can only be with 1 through 7. So these cannot contain 1. We have 2 through 9 here. No 5 or 6 here. No 6 here or 3. This can't be 4 or 4. This can't be 8 or 9 because they share an edge with both of these different 8 or 9 pairs. This also cannot have a 1 here. So again, these are 2 through 9. No 8 or 9 here because it shares an edge with both of these. No 3 here because of 3 in the row, or 3 in the edge. And this cannot be 8 or 9 because it sees both the pink and the red one. This can't be 8 or 9 because it sees both the pink and the red one. So we could do that too. This can't be 8 or 9 because it sees the red and pink there. This can't be 8 or 9 because it sees the red or pink there. This cannot be 1, 2, 3 because we have a 3 here. So this cannot have a 2. No 4 here because it shares an edge with this. Okay. This 8 and 9 pair eliminates 8 and 9 here because it's red and pink. This is 4 through 9. Because again, this cannot have a 3 here, so that eliminates anything that includes a 3 on this Renban. These digits have to contain an 8 or 9. So then it can only be 4 through 8 or 5 through 9. Again, this can't be 8 or 9. It can't be 5. It can't be 8 or 9 because it shares an edge with both of these, or sees both of these, I should say. 5 can't be here. Okay, we need a 5 on this Renban, or this row. So this would be 5, which means none of this can't be 5, and this can't be 5 here. Because they all share an edge with these 3 cells. Both of these do. This cannot contain a 1 also. So this has to be 2 through 9 here. No 3 here because of 3 in the row. This sees both 8s and 9s, so this cannot be 8 or 9. This sees both 8s and 9s, so this cannot be 8 or 9. Interesting. This digit is a 4, so this can't be 4 here. As a 5-length Renban, you can never get to 9, so none of these can be 9. We could have 1 through 8, though, here. This can't be 3 or 4 because of 3 or 4 in the 4 in the row, column 3 in the row. This can't be 8 because of the 8-9 pair sees both of these cells see that cell. So if this is 2, if this is 3, that means it must see 7, 8, 9 here. Which means this can't be 7, 8, 9, it's 5 or 6. If this is... So... If this is 2, that means this would be 3. So this cannot be 3, 4, 5. Could be 4, 5, 6, though. If it's 2 here, it would only see 2 digits. So this can never, if this is 3, it must see 7, 8, 9 here. So therefore this couldn't be 7, 8, 9. If this is 2, it would have to see 2 out of 6, 7, 8 in this direction. So therefore this would be 1 out of 6, 7, or 8, or 5. Because it could not be 9. So it would see the 8 here. Okay, so if this is 3, it sees 7, 8, 9 in that direction. If it's 2, it guarantees sees only 8 there, because 9 cannot be on a 7-length ramband with 2, therefore this can't be 8. And then 1 out of 6 or 7 would be here. Okay. Hmm. Okay, what do we have specifically? So this is 5, 6, 7. If this were a 1, so 5 eliminates 5 as a possibility here. If this is 1, it sees it would have to be non-4. This would have to be 4. So then we have 5 and 6 there. This can't be 5 because of 5 in the column. This is sharing an edge with 8 and 9, red, and it sees 8 and 9 in the row, pink, so this can't be 8 or 9. In row 4 and 6, oh, you can't have a 9 here because 4 can only have a 5-length ramband up to 8, 4 through 8. Okay. In rows 4, 3, 4, 5, 6, 7, and in columns 3, 4, 5, 6, 7, we are guaranteed a 5. We are not guaranteed 5s, though, in the rest of the rows and columns. Because every 5-length Rinban in normal Sudoku or Tessellation has to contain a 5. You have 1 through 5, 2 through 6, 3 through 7, 4 through 8, and 5 through 9, all of which contain a 5. So 5 in, we have the 5 in row 7. The 5 in row 6 is one of these 5 cells, which is pretty broad. The 5 in column 7 is one of these 3 cells. 5 in row 3, as I said, is one of these 3 cells. 5 has to be one of these 4, but that's not very restrictive. If this is 3, that would make this 2 and this 3. So this would be 8, 9 guaranteed here because there's no other place for 8, 9 in the column. And therefore, and this would have to be 7. So we'd have 7 here, 7 here. Okay, so how does that work? So say we have 3, then this would be 2, that would be 3. This would be 8 and 9 because we have to see 7, 8, and 9 here. This would be 7, we'd have 7 there. So no 7 here, we would have to have a 7 there to allow this red band to work. Neither of these could be 7. We still need a 7 in one of those two. So 7 could not be here. So that could work. This would see 2. So this could not be 7 here. That seems fine. If this is 2, then 1 out of these 2 is guaranteed to be, has to be 6, 7. That forces this to be 3, that to be 2. This is 3 away, so that would be 7 there. This would have to be not 7, it would have to be 8 or 9 here. Ah, and we'd have a contradiction. So basically, if this is 3, this has to be 7, and this must be an 8 or 9 to be 4 away from the 3. But the 8 or 9 here would guarantee one of these would have to be 7 to form a Ren band of 7, 8, and 9 at least, or 6, 7, 8. And we can't have that because this 7 eliminates that possibility. So this can never be 3, which makes this 2, this 3. That means this sees 3 cells this way from 7, 8, and 9. So this cannot be, this has to be the other 8, 9, because these can't be 8, 9 because they all see the red and the pink 8, 9s. Obviously, this can't be 7 anymore. It's 5 or 6. 6 would be at most going up to 8. So this is 5 or 6 here. This is the 8, 9, which is not red. So this is pink. This must be 6 or 7 here then. And since this is 6 or 7 here, 2 eliminates 2 as a possibility here. 1 is 4 or more away from 6 or 7. Which means this doesn't work then. It sees both these cells which are 4 or more away from it. So this can't be 1, which makes that a 3. So there's no, this therefore must be 7. This must be 7. Again, as I said, that eliminates 7 in the rest of the column. 7 can't be here. This is 6, 8, or 9. We don't know which. This is pink. This is red. There's no other cells that see it. 7 eliminates 7 here and here. We need a 7 in one of these cells to be a Ren band, so this must be 7. No 7 here. This is 5, 6, 7, or 6, 7, or 7, 6, 7, 8, or 7, 8, 9. So there's no 4 here. 7 eliminates 7 in the rest of the row. These can't be 7 because of 7 in the row. We need a 7 somewhere here, so one of these 2 is a 7. This can't be 2 or 3 because of a 2, 3 pair in the column. We have a 4, 5, 6 triplet now, which eliminate, and this can't be 3. So we have a 4, 5, 6 triplet in column 5, which eliminates 4, 5, 6 in the rest of the column. So this can't be 6, it's 8 or 9, which makes that the red 8 or 9. This can't be 4, 5, 6, or 8 because of the 8, 9 pair in the column now, which forces this to be 7. This is 1. 7 is consecutive with 5, 6, and not 4, not 3. So this has to be 8, 7, and 6 here, which eliminates 6 here, so that's 4. No 4, 6 here, no 4, 6 here. 4 eliminates 4 in the rest of the row, so this is 5, that's 6. No 5 or 6 here, no 4, 5, 6 here. This is 5 and 7, so this cannot be 5 or 7. If this goes down, if this includes a 5, it would have to be 5, 6, and 7 there, so this can't be 5. 6 eliminates 6 here and 6 here. 4 eliminates 4 here because it's consecutive with it, or shares an edge with it. So this is 5, that's, oops. This is 5, that's 7, which makes that 5. So 5 cannot be here, 5 cannot be here. Where's 5 in column 3? It has to be here, guaranteed. So this is 5, which eliminates 5 here. It eliminates 5 here. This is 4. There's no more 4 here because of 4 in the row. 8 is here, which means the red cells must be 9. So these must be 9. The pink cells are 8. That means this can't be 8 here. This can't be 9 here. This is 5 eliminates 5 being here, so it's 8. This must be 3 through 9 now. So this has to be 3, which makes that 6 because we have a 9 there. This is 3 through 9 now, so this can't be 2. 7 and 8 eliminates 7 and 8 here, so it's 6, which makes this 4, which makes that 6, which eliminates 6 here, so it's 9. This can't be 8 or 9, it must be 4. No 6 here. You have 6 here, which means it cannot be 1. So it's 2 through 6, 3 through 7, or 4 through 8. This is 3 through 9 because we have a 9 in the row. So no 2, no 2 or 9. It's 3 or 8. 3 is not 3 away from 6. Sorry, it is 3 away from 6, so it can't be a 3, 4, 5. Cannot. 6 on a rim band is 4, 5, 6, so this can't be 3. So this is 8, which makes that 3. 8 must be with 7 and 6 to be a rim band. This can't be 7, so that's 2, which leaves this as a 1. And that's how you solve it. Pretty straightforward for tessellation. There's certain restrictions you have on what digits can be on these Dutch arrows. So it sort of led things down that path, which was pretty simple to go through. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.